This week, on the occasion of World Brain Day, the health programme will be diving into the heart of this still mysterious organ with help from the most perfected instruments. Financially support research on the brain. The FRC, the French Federation for Brain Research, has just organised its own telethon called Neurodon to help finance laboratories like that of Antoine Triller. Here's a guided visit dedicated to the neuron. Here you can see an experiment, the activity of neurons, directly in preparations, where we separated and reconstructed neuron networks. We call this a culture of neurons, and this is what you see here, fluctuations, and the light from these fluctuations translate the fluctuations in activity. What is a neuron? It's the cell you can see here with these extensions, which go from the cell. Here in our laboratory, we're studying how the communication between these two cells is made. Here are the cultures of neurons from mice. The researchers are studying the communication points between two neurons. We call this synapses. It's here that the chemical message is transformed into an electric signal, information. Here you have a neuron. And when you look here, you can see the neurons are connected together by these small extensions. They are synaptic contacts. Synapses equipped with receptors whose behavior can be studied in this laboratory in real time. It's a real feat. These small white spots that are moving around are receptors on the surface of cells, and we've understood the regulations of this permanent molecular movement, as well as how mechanics of the bad functioning of these regulations could possibly be at the origin of pathologies, like Alzheimer's disease or epilepsy. Never before have researchers gone so far in the analysis of neuron function, and to go even further, Antoine and Philippe Rostin have made a new acquisition. Philippe is the one who takes care of developing high-pressure freezing technology. And we were able to acquire this machine you can see here. It's not that impressive when you look at it, but it's extremely powerful and enables us to freeze specimens of nervous systems very rapidly, in a few milliseconds. In record time, the contact between two neurons is frozen so as to be observed like a photo in this super electronic microscope. The microscopes we saw earlier enable us to visualize and enlarge a few hundred times, and the one you see here enlarges a few tens of thousands of times. Trying to know even better how neurons work, this is a key element in brain research and hope for treatment in a few years' time.